How many of you are working in the thin films technique, any of the thin films technique? So there are, let's say, 8-10 hands I am seeing. So if you want to enter into the device fabrication, this is one of the very essential steps that you have to deposit thin films. So thin films are required, as Professor Vamsi was telling in a quite detail, that if you want to make a kind of a multi-layer device or single layer device where you require the material should be less, then you have to make a thin films. So this is one thing. So you have to make a thin film of the material which you want to make a device. The second thing is that if you want to make a contacts, electrical contacts, then also you have to use this thin film technique. So he has already described in detail about this sputtering technique. So I am going to talk more about this E-beam deposition technique. So some of you may be familiar with this thermal evaporation system. So if you have to make a thin films of a material, what you have to do, if you take any material, you start heating it, then the material will melt and vapor will come, and if you put any substrate, thin film will form. But we cannot do this process in an open atmosphere, reason being lot of contamination will come in. So if you start making, let's say, gallium thin film in the open atmosphere, gallium will easily melt. You increase the temperature to, let's say, 400 degrees C, the gallium will start evaporating, the thin film will form, but what will happen, whatever the oxygen is available from the atmosphere, it will react with that and will form gallium oxide, not the gallium film. So what you have to do, you have to create a vacuum so that there should not be any extra gas which can make any kind of interaction with your material and can form any impurity. So that is why we do the vacuum things, and apart from that, the other important thing is this: whenever you start evaporating and the metal atoms start moving, start in the form of vapor, then if there is no other gases are present, it will move in a straight direction. Otherwise, what will happen, a lot of shadowing effects will take place. So these are the two reasons for which we do the vacuum, and typically we use rotary pumps and diffusion pumps, and there are many other pumps like turbo pumps, etc. we use for creating the vacuum. So for if we have to create a vacuum of, let's say, of the order of millitorr, then we use the rotary pump. But normally for these kind of system, we use the turbo pump or the diffusion pump, because we want to go up to the 10⁻⁶ torr or so, and sometimes even we go 10⁻⁹ torr, then turbo pump and some other pumps are used along with that. So that is another thing. So for this thermal evaporation thing, we use here, what you see here is a kind of filament in which the electrical current goes and the materials are get heated, and once it start melting, it start evaporating and the thin films are formed. So that is a very technique. In many of the universities and laboratories they use this kind of technique, but there are certain disadvantage of this technique. That is why we want to talk of the E-beam technique. So for these are the typical picture of different this kind of boats which we use for depositing this film. Helicals are used, or sometimes these different modes of boats are used where we put the material to deposit. Obviously, it is a very obvious thing that the melting temperature of this boat has to be higher than the material that you want to operate. Otherwise, what will happen, that your material before it start evaporating, your boat itself will go. Okay. So that is a very obvious thing. So that kind of precaution is taken. And here is a picture of a system where we use a multiple kind of evaporation. You can have different boats, and you can operate either simultaneously or one by one to deposit multi-layer film or a kind of composite materials. That is also you can do that. So these kind of things are possible in a thermal evaporation system, which is very common in many of the universities and all that. But the disadvantage of this one, there are a couple of disadvantages. One disadvantage is this, that what happens, because you basically heat the boat, and when the boat is heated, then you keep your material on the boat. So what happens, the material gets heated by taking the heat from the boat. So if there is any contamination on the boat, it will go in your material, and your material and the film will get contaminated. This is one problem. Second problem is that some of the material have a very large melting temperature, and that is very difficult to achieve by this thermal melting, because thermal evaporation, when you use, you start flowing large and large current if the temperature is very high, this boat will break. So that's another difficult problem. Third problem is that the evaporation rate is very difficult to control in the thermal evaporation system. The material melts and start evaporating suddenly. So if you want to deposit a very thin film, let's say 2 nanometer, 5 nanometer, that's not possible with the thermal deposition thing. So that's another thing for which we require the E-beam technique, where we can do more controlled deposition. It could be something like as low as 10 angstrom per minute kind of thing. So you can go a very thin films, and for many applications such kind of things are required. Okay, so how we do that? So this is a typical system is shown here, which is available in the NRF, and tomorrow you will get opportunity to see this system. This electron beam operation system, and this is the hearth where we keep our material, and how it happens. So there is a basic difference comes here. That's what I try to show in this picture here. So there is this is a hearth here. So where we keep the material here, and what happens since a electron beam evaporation system, so we have to create a electron beam. So we have a tungsten filament here or some other filament here. When it is heated, it is start emitting the electrons. And what happens, the electrons are using some magnetic field. The electrons are rotated by 270 degree, and then this electron beam is directed, and then it start falling in it. So what is happening on your this material which you have kept for evaporation? It's not that I am not heating anything here. What I am doing, I am using this electron beam to heat this one. So the advantage is that electron beam goes and just fell on the material itself. Okay, and when it falls, then it gives the energy to the material, and the localized way the temperature of the material increases and the material start operating. So I don't heat all the material together, I heat only a part of the materials using this electron beam. So that contamination which could have come from this boat is not coming here. So that's one advantage. Second advantage is that I can control very well the energy of this electron beam. So I can in a very controlled way I can do the evaporation rate. Okay, so very small evaporation rate I can do that. So very thin film can be deposited by using this one. So these are the couple of advantages of using this electron beam one. And here I can the facility that we have available here, I can go the electron energy from 4 to 20 kilovolt kind of thing, and then it's possible to make the electron beam to fall with different energies, and that way I can control the evaporation rate. So that is there, and so that this is the basic principle. And next thing that I can talk about it in this electron beam, the facility that we have here, it is possible to deposit the multi-layer films in a very nice fashion. So what we can do, we have a 4 hearth. So in each hearth I put A, B, C, D, 4 different materials, and then I can make a computer program here. So what will happen, the first hearth come, electron will fall in it, and what will happen, it will start, operation will take place, and then up the program also I can write it, and the hearth will rotate, the next material will come, and that way deposition possible. And we can do in a controlled way such that I can deposit 3355 nanometer type of layer. So that multi-layer kind of things can be deposited. So that is a very good potentiality of this facility that we have here. So this is a photograph of this deposition chamber here. This is inside this one, and so we have a thickness monitor system. We use quartz crystal monitor, and those of you who have used this thin film, they know it that for monitoring the thin films normally use a quartz crystal technique. So here what happens, that the frequency of the quartz crystal keeps on changing if more and more material gets deposited. So it's all calibration is there. We need not to do this thing every time. There is a complete chart is available. So I can tell that what kind of materials I am depositing. So accordingly I can control what kind of frequency change I am getting. Then I can control what is the thickness of the film we can deposit. So these are the photographs of the pumps is shown here, dry cold pump, and also this turbo pump is there. So these things are here. So tomorrow when you will visit the lab, you will see it in more detail. And typically the system that we have here, I can get 10 to the minus 7 millibar type of pressure there, and we deposit this titanium, chromium, molybdenum, gallium, and different kind of materials we can deposit. And as I was saying, that the possibility is that many times what we have to do, even for making a contact pads for our device characterization, we have to use these two one over the other thin films, for example chrome, titanium, or any other two materials. Okay, so this is there, and the water earth is cooled, so there is a very less chance that the contamination can go and on this one. And this is the screen of the main control, where we can make the program and put all the parameters and all that, so that the deposition rate etc. can be controlled. These again switches and all that kind of things are there. So perhaps you will see it when then you will realize it more. And this is the photograph when the electron beam falls, it's all get melted. There is a screen, there is a window there. From that window you can see that the material is melting and it start evaporating. So these you can watch, and then there is a control there, and finally you can get very nice film. So you get on a bigger area, so you can have multiple substrates. So what we do, that we put 2 or 3 substrate together, so that it can be economized. Okay, so with this one I will stop because there is a less time. There is another talk here, after that lunch is there. So if there is any question you can ask now, but otherwise what I suggest that please note it down, and tomorrow we will have more interaction meeting in the morning itself, and then if you have any question you can ask in more detail, and we all will be there to discuss this thing. Okay, thank you very much.